Okay, you're almost welcome to our last lesson at the Holistic Learning Platform. This is going to be a math lesson for Senior 3 class. I want to welcome you all to this lesson. My name is Masav Erisa. I work with Mbali Secondary School. I also work with the Holistic Learning Platform. I teach math and ICT. I was here with you in the first lesson. Then we broke off for elections. Then in the previous lesson, the madam came here and interacted with you. This afternoon, we are here to finish this topic, this chapter, and I pray that you learn something before you go back to your respective schools. I want to welcome a volunteer to give us an opening prayer. When you're giving us an opening prayer, please mention your full names, the class, and where you come from. Yes, Martin, you can give us the opening prayer.
Good afternoon, sir. My name is Opit Matthew. I'm from Bishop Cipriano, Chiangiri.
Yes, Matthew.
Let's humble ourselves and pray. Heavenly Father, King of Glory, we thank you for today. Thank you for the gift of life. We thank you for everything you have done for us, Father Almighty. All your provisions, Father. We want to pray that you may guide us and protect us throughout this lesson. Bless our teachers so that they may teach us well and enable our minds to understand everything in this lesson. In Jesus' mighty name we prayed. Amen.
Thank you very much, Matthew, and greetings to the team that said when you go back. Can we type amen in the chat to confirm that you believed in that prayer? Then I'm going to give chance to one boy and maybe two girls to make it one boy, two girls. I'll just say hi to the class. You mention your name and where you're coming from. The one boy, put up your hand, then the two girls to make it two. You at least say hello to the class. You test your microphone. Yes, Aaron, you can start from there.
Sir.
Good afternoon.
I'm fine. My name is Mongo Aaron. I'm from Navy.
Aaron is from Nebi.
Yeah.
Yes. Which school is that, Aaron?
Parosco.
Okay. Aaron, you're most welcome and greetings to the team in Nebi when you then go back. This Paul.
You're
Paul, you
welcome.
can also say hi to the class.
Thank you.
Good afternoon, teacher.
Good afternoon, Paul.
Good afternoon, teacher.
Good afternoon, Paul.
I'm Luitaita Pomukasa. Good afternoon, teacher.
Yes,
I'm
Paul, I can hear
Luitaita
you.
Pomukasa from Kalemba.
Where is that?
From
Paul.
Central Secondary School.
Which district is that?
Vida Maria.
Vida Maria. Okay, Paul, you're most welcome. Can we give chance to one girl or two? We start our lesson. Yes, Nancy. Nancy, please go on.
Good afternoon, teacher.
Good afternoon. Greet the class, not me.
Good afternoon, everyone. My name is Ampire Nancy from Kitende SS.
Kitende SS. Yes, welcome, Nancy. Greetings to the Kitende team that side when you go back. The last girl. The last girl, please put your hand up and say hello to the class. Shivan, Shivan, please go on.
Good afternoon, everyone.
Good afternoon.
My name is Nyakaranji Shivan from Mengo SS.
Mengo SS. You most welcome Shivan and the rest of the team. Welcome everyone, and I'm going to leave the microphones closed for now, not until I ask you to maybe say something is when you put your hand up. And maybe for now, I'm also going to close the chat temporarily such that we can concentrate We will start by probably, this is what we looked at last time. These are topics that you needed to cover in Senior 2. And for those who were here, who were not here in the previous lesson, you look for that recording. Make sure you covered all the topics. If you didn't cover in your school, please look for the books and try to cover them privately. You can still learn. These topics are easy to learn. Please learn them. Then in Senior 3, this is what we expect you to study for Term 1 and Term 2. Then Term 3, you will pick that syllabus and look through. I'm going to share the syllabus here so that you can plan so well. At Holistic Learning Platform, we always prepare you for the next lessons that will go back to school and meet them. So we thought that we pick the theme patterns and algebra, and we talk about equations of a straight line, which we did so well. We introduced it, and now we are here to finish this topic in the next 1.5 probably hours. So I request that you be very good students, and probably we finish this such that when you go back to your classes, respective schools, I've seen people from Nebi, Vira Mari, I've seen Kitendefes, then Mengo, and the rest of you who are here. When you go back to respective schools, we want you to get the outstanding result in this chapter, equation of a straight line. Please prepare all the questions, and I'm going to assume as a teacher that you've all come with your graph papers because we need to use the graph papers anyway. And for those who don't have graph papers, I suggested that you download GeoGebra app. It can be installed on your phone. You can follow. If you fail to follow on your phone, then probably when you go back, after the lesson, you try and see if you don't have a graph book. GeoGebra can come in to help you. So, in the last lesson, you wrote equations of the straight line, and I'm here to review what transpired in that previous lesson. Can someone remind us? Can someone remind us on how to write the equation of the straight line? Put up your hand and remind us of how the equation of the straight line is supposed to be written. Maybe if you can write it down, then when I give you a chance, you just tell us how the equation of the straight line is supposed to be written. It's well and good. Please put up your hand. I will help you write from this side. Yeah, in the previous lesson, you read or you talked about the equation of the straight line. What is the standard formula or the principle we follow when we're writing the equation of the straight line? It starts with y is equals. Can we get someone to complete this? Alisa?
The general equation is y is equal to mx plus c.
Alisa is telling us that the general equation is y is equals mx c. She has told us y is equal to mx plus c, and this is the correct general equation of the straight line. And can we get someone to quickly take us through what y means, what m means, or anything that you can tell us for those who are coming here for the first time to understand? Alisa still wants to take us through what the meaning of this. Can we get some other person, or else I give chance to Alisa to take us through what this formula means? Any other hand? Any other hand? If you believe you understood this formula. You understood this formula, please. Okay, Alisa, take us through.
So the y is any point that lies on the line. Then c is the y-intercept, basically where the line cuts the y-axis. Then m is the slope or gradient.
Yes, m is the slope or the gradient. And you forgot to say something about the x. Alisa says something about the x.
The x or the y are any points that lie on the line.
Okay, thank you, Alisa. That is correct. Alisa, which school is that? Oh, the girl is. Alisa, please. Which school is that, Alisa?
I go to Mount St. Mary's College, Namagunga.
Mount St. Mary's. Okay, that is very good, Alisa, and she has taken us through what the meaning of y is equals mx plus c. Of course, this is general knowledge. I pray all of you remember this. So what we are going to do, I'm going to, she has told us the gradient or the slope, and it shows the steepness and the direction. Of course, if it's positive, upward, and if it's negative, downward. We talked about this in the previous lessons. Then the the C is the y-intercept, like she said, where the line cuts the y-axis, and x is any point on the x-axis. Yes, so I wanted us to review this lesson by getting the paper, and you quickly write for me the equation of this line. I'm going to display a line, a very simple line. You get a paper, of course, not a paper in your book. Please, in your book, you're going to write for me the equation of this straight line. I'm going to give you 2 points. Write that equation. Start by getting the gradient. After that, use the previous lesson's knowledge and get that line. I'm going to give only one question, and the question is here. Find the equation of the line passing through A, 2, 3, and B is 4, 6. I want to see the answers, and probably, please write it on a good paper because you're going to take a photo and put it on WhatsApp such that we can all of us see. And when you're writing, put your name somewhere. If we get the first people, then we proceed. There are many questions here, but let's use this one to review the previous lesson. I'm going to open the WhatsApp immediately. I'm opening the WhatsApp group here. Please post those answers here such that we can be able to see. For those who are finishing, please post your answers on WhatsApp. And if you finished and you're getting a difficulty in posting the answers, you have to put up the hand and you let me know where the issue is. Okay, the equation is saying you find the equation of the line passing through the point A is given and B is given. Like I said, you start by getting the gradient. Yes, Melissa?
I want to send the work, but group is not open.
Which group is that? I've opened. Are you in 3A?
Yes.
3A is open and maybe you go back again.
Okay.
Mm. Like I said, in today's lesson, you should have a graph paper and at least have a calculator with you. So please make sure you have a calculator, make sure you have a graph paper or a graph book. Actually, a graph book would be better. So try this exercise. And for those who have finished, please post the answers such that we can proceed. Okay, I'm going to send the link for those who have not joined. And the link that I'm going to send is for Senior 3B because this first group is full. Yes, yes, please. Ni Malu. Please unmute and speak. I can't hear you. Graham, I can't hear you. For those who are not on the WhatsApp group, I'm giving you this new link. The other group
You
is
requested
full.
me to the group.
Yes, I'm giving you the link. For those that have not, okay. For those that have not joined, please join using that link that I have put on WhatsApp. And for those who have posted, let me sample your answers here. I want to see if people are doing the right thing or probably You can't remember anything. Okay, I've seen work for the own Melissa. Yes, Melissa has got the equation of the line is 3 over 2x plus 0. It means the y-intercept is not, the intercept is not given, and 0 is correct. We are going to try it out and see. For those who have finished, please try out these other questions. For those who have not finished, please finish question 1 and we proceed. Yeah, then I've also seen work from Mukasa, and he has got the gradient. Yeah, at least we have the gradient from Mukasa. Then Mukasa, I think, is using 2 pages and is having his intercept, y-intercept as 1, which is C. We will try out and see which one. Yes, Mukasa, we've seen the work, it's okay. So we are going to try out and see if that is correct. Please, whoever is going to WhatsApp, only post the answers, not anything else. If there is any other conversation, please bring it back here to class. Yes, please.
Chair, I kindly request that you add me to the group.
I shared the link. Please join using that link in the chat. Okay, I'll close the WhatsApp groups temporarily to allow people maybe join for those that have not joined. So we are going to try out number 1 to review what we've studied in the previous lesson. Anyone ready? Put up your hand and take us through question 1. Anyone ready? If you know how to do item 1 or if you've already done, please put up your hand. Take us through. Yes, Arafat.
Item 1, I have find the equation of the line passing through F through
Arafat, your
3
internet, your network is not good.
Gotcha. Let me summarize what I have.
Yes, please.
M is equal to y2 minus y1, x is equal to.
First, give me your equation.
M is equal to y2
Arafat, your
minus
network is not good.
y1.
Can we get someone with a better network as Arafat organizes himself? Any other person? Let me try Mali. Arafat, stay on call in case this one is not good. We'll go with that. Yes, try your network.
Teacher,
Ali?
the gradient, I used m equals to y2 minus y1,
First, give me your gradient. What is the final answer?
3 out of 2.
3 out of. Okay, you used gradient. You used y what?
y2 minus y1 divided by
Yes,
x2 minus x1.
correct. So how did you substitute?
In y2, I have 6.
6.
In y1, it's 3. x2 is 4.
Yes.
x1 is 2.
Okay. When you simplify,
I'm getting 3 out of 2.
3 out of 2. Okay. Anyone with 3 out of 2 as the gradient, please put your hand up and we see if she is correct or not. Anyone with that as their answer for gradient? 2 people, 3 people, 3 people. Any other person? 4 people, 5. I think this is correct. Everyone has that. Okay, let's continue, Ali. So how did you proceed?
I first wrote the formula of getting the equation of a straight line, which is y equals to mx plus c.
Yes,
Then I'm going to use the coordinates of A.
yes, these ones.
Mm,
Yes, please.
I started substituting. Where y is, I placed 3.
Yes,
Equating to the gradient, which is 3 out of 2,
3 out of 2.
times the 2, which represents the coordinate on the x-axis,
Okay,
plus c.
okay.
I crossed the 2 by the one up. I divided.
Okay, and this gave you 1.
It gave me 1. 3 times 1, I remain with 3.
Okay,
So
so
teacher,
this is
3 plus c.
so our C becomes 3
3 minus
minus
3.
3. So C becomes 0.
0.
Can we confirm if anyone's answer is like that? I'm going to start by lowering everyone's hand. Then put up your hand if you got your C as 0. How many people are these? 5 people. Okay, 5 people got that. 6 people. Okay, I think this is correct also. And according to the mathematics here, I see C is 0. So proceed. How do you now write your equation?
I wrote my equation as 3 equals to 3 out of 2.
Your equation, remember you use this standard, which is equals mx
mx plus c.
plus c. So your y is y,
3
your
y
gradient
equals
is
to 3 out of 2
mm,
x plus 0.
plus 0. Yes. And of course, some books, of course, in mathematics generally, 0 is always silent. So I would suggest this equation is written as y is equals 3 over 2 x like this. Even if you don't add the 0, this is a correct equation of that straight line. Anyone will know that this line does not touch the y-axis, and that's why it is 0. Thank you, Ali, and this is correct. Please, for those who have any question, please ask. And if there is no question, we sample the last question and we see what we are to learn to close this. Please put up your hand if you must ask any question. I've lowered all your hands to give chance to anyone with a question. No question. I don't see any hand. I think there is no question. Anyone who got that as the equation of the straight line, your hand up. Anyone whose answer is like that. Ruth, okay, this is another hard name. Peruth. Venus has, Sabira has, Ari has, Serif. Jimmy, who else? Who else got the answer? Kevin, Mukisa. Mukisa, if your answer was different, I'm sure. Let me see Mukisa. Mukisa, please put your hand up. It's like I saw on WhatsApp your answer was different. Mukisa. Is your answer like this? Mukisa, please talk to us.
Teacher, I want to understand. Here they have put 3. Now, 3
Mm,
was to substitute y, right? Now, in
yes.
the equation, the last answer, they are not putting the 3y.
Okay. Ali, are you able to respond to that? Mm. Ali, are you able to respond to Mukisa? Okay, anyone who can respond to Mukisa is asking why is it that in the equation we are writing y where there is y and not 3. I'm going to Melissa. Melissa, are you able to respond to Mukisa? Melissa
Pardon the question.
is asking why is it that here we don't substitute 3 here and yet y is 3 and we are writing our equation without 3 instead. I think that is where Mukisa's confusion is.
So I'm not really sure.
Okay. In computer lab. Okay, sorry about that. I received a call here. But Mukisa is telling us why are we not substituting 3 here? Yes, the equation of the straight line, I am assuming Mukisa was not here in the previous lesson, but the equation of the straight line is written as y is equals mx plus c. Yeah, like that. Now, the only variables, only constants here that we replace is only m and c. These ones are constants, but the y and x are values that vary. They vary. You get it?
Yeah.
So that's why this girl struggled to get the M. You saw me ticking her when she got M. Then she struggled to get the C. Then she comes back to substitute. We don't need the Y, we don't need the X. You get?
Okay.
Okay, so can we assume everyone can now do the next one? Probably. Let me display the second one. And I'm going to open the WhatsApp still and test and see if people can post the second answers. And for those, the second question, sorry. For those who did the first one and you didn't submit your answers, please, you can post them on WhatsApp. Like I said, on WhatsApp, don't take there any other conversation, whether you are saying what, just post the answers. I'll open for feedback for those who have issues. But for now, just take a photo of what you've done, post it on WhatsApp. Yes, Arafat?
Teacher, number 2.
Yes, please.
The first step, you first find the gradient.
Arafat, first hold on. We see if people can post the answers on WhatsApp before. I'm going to give you a chance to take us through. Your network seems to be better at the moment.
Okay, teacher.
And you can even start by posting the answer that you have on WhatsApp.
Okay, teacher. So teacher, let me mute myself. When you need me, you'll unmute.
It's okay. It's okay. You can leave the hand up. Yeah, Friday has posted his work, and yeah, the constant was 0, which is correct, and the gradient is also correct. This is good. This is good. Please make sure you show me your answers so that I know how to help you. For those who have done number 2, please post. Someone had, I think, sent me directly. Yeah, it's okay to send me directly, but if you put in the graph, the better. The C is 0, correct. The gradient is also seen there, correct. This is good. This is Joy. I think Joy. Joy had also sent me privately. That work is correct. Angel Nansana has also Venus. I think it's Venus. Has given us work for number 2. Wow, this is good. I can't wait to see if this is correct or not. Item 1 is correct for Venus, and item 2 must be correct also. I can't wait to see if that is correct. Any other work? People who are on WhatsApp group B, I am not seeing your work. Don't know whether we have people in there. I'm about to close these WhatsApp groups and we continue with the work. If you still have some work, please post it very fast. Okay, like I said, you need to know how to get the gradient. You need to know how to use the gradient to get the constant. You need to know how to write the equation of the straight line. And of course, I've given chance to people to post their work on WhatsApp. But of course, yeah, Ali has posted. Let me see if this is correct. Ali has posted. Yes, let's wait and see if this is correct. At least someone on group B has posted something. Any other person? For those who have finished number 2, please try out number 3. Don't get bored. Mukisa, finally, from given up the gradient, constant. So your work is not complete, but at least I can see that you have the gradient. But that gradient, please simplify it further by dividing through by 3. You've left it as 9 out of 3. I know you can simplify that better than that. This is still good. This is still good. I'm about to close this WhatsApp groups. Please, if your work is ready, post it and we look through. Or else I'm going to close, then you'll post later. Opening the chat, for those who can manage to type their answer directly. I'm interested in the equation of the straight line. You can type it in the chat directly, such that we can see. For those who could have failed probably to type on WhatsApp, just type y is equals what. I've also seen Mukisa. Yeah, this is good, Mukisa. Now you have the gradient, but you don't have the constant. Yes, the constant is also seen. And please simplify your gradient. Simplify. Simplify your gradient, so you can get the best answer, though this is also okay, but you can simplify it further. Okay, people in group A must be doing better. Yeah, the equation of the line is here. We are going to confirm. This one has done question 3. Venus, no one is going to manage you today. While we are still doing number 2, Venus has finally wrote number 3. This is good, Venus. I must say you're doing so well. Ella Powers has told us the equation is equal to 3x plus 2. We are going to confirm and see. Yeah, Mukisa finally has simplified. We are going to see that is good, Mukisa. And any other person? Matthew has given us negative 3x. I know Matthew must be struggling to type, but it's still doable. You can do it. I'm seeing many people are online, but no one can post. In group B, we have 15 people online, and in group A, we have many people are online here. I really wanted to give you a chance. Melissa has got number 2, negative 3x plus 2. I think Melissa, we are going to confirm that. Alphat is going to take us through. Galaxy A02 has the answer also. Okay, I'm going to close now. Someone is typing in group A, but let me close group B. For now, I'll open it when I feel you need to say something. Group A, whoever was typing, post faster or else I close you out. Okay. 42 people are online in group. 42 people are online, but only 2 answers. Okay, maybe. Let me close it temporarily. We continue with the lesson. Okay. Arafat, take us through item 2. Arafat?
Item 2. Find the equation of the line passing through C, negative 1, 5, and D, 2, negative 4. Step 1, we first find the gradient using the formula M y2 minus y1 divided by x2 minus x1.
Yes, please.
So where we have M is equal to negative 4, negative 5 minus 5 divided by 2 minus divided by 2 minus open brackets negative 1. M is equal to negative 9 minus 3. Negative 9 divided by 3.
Divide by 3.
Yeah.
This is divided by 3. Of course, anyone in senior 2, senior 1 must know that this will become a plus.
Negative.
I think that is how it's getting negative. That is getting 3. We can proceed. Simplify this. M becomes
negative 3.
Negative 3. Okay. Anyone who got negative 3 as their answers for gradient, your hands up. Yeah, Perth, 4 people. Kevin, Nancy, Zawedi, Ari, Marisa, and so on. Yes, this is good. I think the correct gradient is negative 3. Yes, negative 3, because if all these hands have it, then why not give him correct tick? Arafat, we can proceed. Arafat, yes, open your microphone.
The second step, we use the point slope form, where we have y minus 5 is equal to negative 3. Is equal to negative 3, open brackets, x minus open brackets -1 close brackets.
Where is this coming from?
It's coming from, we are using the slope method where the form is y minus, sorry, the formula is y minus y power 1, which is equal to m x open bracket x minus x power 1.
Not understood that. Where is the C going? What are you finding?
Pardon, teacher.
I expected you to be finding the constant at that step. Are you finding something else?
Yeah, teacher, I'm still continuing.
Okay.
Y minus 5 is equal to -3 open brackets x plus 1.
Like that?
The other step, we simplify the equation. Y minus 5 is equal to -3x minus 3.
Minus 3? I thought
Minus
5 is
3.
coming this side. I thought 5 is coming this side to be added here. Or okay, Alphat, I don't see.
I still
Probably
get
I'm
the
going
same
to.
answer.
Of course, that is fixed now. Y is equals -3x plus 6. Is that your final answer, Alphat?
Teacher, I got 3x plus y minus 2 is equal to 0.
3x.
Plus y is equal, plus y minus 2 is equal to 0.
Is equal to 0. Okay, we'll compare it with what your friends have and see. Let me see. Thank you, Arafat. Let me see. There was someone putting up an hand here, maybe as a burning question. Gidud David Joshua. David Joshua, please put your question.
Excuse me, sir. Sir,
Yes,
what
please.
if I leave my gradient as -9 out of
Negative what?
3?
Yeah, that is a fraction that is not yet simplified. If you say your gradient
-9,
is
-9 out of 3.
-9 out of 3. This fraction is correct, but it's not simplified. You can just simplify. We're just simplifying this by 1, here by 3. I mean by 3 to give us m is equals -3. We're not doing much. Just simplify. Melissa, you want to get for us the constant?
Yes.
Please go ahead. I want to compare your constant with what Arafat has got. Start from the gradient which we have here.
Y equals, no. We find, wait, yes, y equals mx plus c.
Yes.
Then we substitute into y and x.
You're using C or D?
I'm using D.
D.
Yes.
Okay, 2 and -4. Yes.
-4 equals -3 times 2 plus c.
Correct.
Negative
It's
4
-4.
equals -6 plus c.
Yes. So C
Negative 4
becomes
plus negative
4
6.
plus
Oh, 6.
Okay.
2. The answer is 2.
Says 2.
Yes.
Okay.
Then the
The
equation of the
constant is
line
2. Let me see if someone has the same answer. Anyone who got the constant as 2? 2, only 3 people, 4 people. I think that is correct. Once you have the constant as 2, the group is confirming. Okay, we can proceed. Let's proceed.
Then the equation of the line
Mm.
is y equals negative 3x plus 2.
Okay, and this is
Yes.
correct. This is correct. I know people have this as their answers. So when you look at Alphat's equation, yes, when you rewrite this, y will be plus 3x minus 2 is equal to 0. So Alphat's equation is also correct, but he has rewritten it not in the formula. You see, a standard formula of the equation of the straight line is written as y is equals mx plus c. So y starts. Y is supposed to start. So if y is supposed to start, please make sure it starts. That's why we are starting with y. Y is supposed to start. M comes next after equal signs. X comes immediately plus a constant. So Alphat, your formula, I did not understand it so well up here, but your formula, please make sure you reorganize it such that it is in this format. Thank you. That was a good one, and we will not take a lot of time on this. So allow us to go to what we are supposed to study today. Today we are going to talk about, for those who still want to try out, there are 4 questions. They are there, take a screenshot, and it will help you review what your friends studied in the previous lesson. What I want us to study this afternoon is when you're given a gradient, when you're given a equation of the straight line. Now here I'm going to open the WhatsApp, I'm going to open the chart. I'm going to give you an equation, and you tell me what is the gradient of that equation. Equation 1 is y is equals 3x plus 5. What is the gradient? Put it in the chart. Because this is very easy until when it becomes hard. Put this in the chart. For question 1, what is the gradient? The gradient is 3. Rahim says, Marisa says 3. Okay, that is good. Equation 2 is here. Now, here you need to think a little. Number 2, y minus 2 is equals 4x. What is the equation of this? What is the gradient? Only one person has told us 4. Muxa says 4. 4. Marisa says 4. Correct. People seem to have discovered that even number 2, the gradient is 4. Maybe this is simple. The next one is 2. Now Mukisa has gotten it as 6. Now here, let me close the WhatsApp. Let me close the chat. Can you first think again? The question is saying 2y is equal to 6x plus 8. I'm using the sample that is here. Mukisa has said 6, Santos has said 4, Janet has said 6, Rahim has said 3. Now, I want to get the correct answer. Please put it on a paper and try it out. I'm opening the chart and I want to see only the correct answer. Okay, the chart is open. What is the gradient to this line? 3, 3, 3. Okay. People have 3. Let me close it at this. Someone should tell us how to get the gradient of this number 3. Put up your hand and tell us how you got it if you know. Someone using Didi, you gave us the correct answer first. Didi, what is your name?
My name is Desire.
Desire? Yes, proceed, Desire.
So we have to divide by 2 on all the numbers given, because y, we can answer that y has to remain as y without without any number next to it. So before y we have 2, so we divide by 2, and also we divide by 2, and again divide by 2, and remain with y is equal to, yes, y is equal to 3x plus 4. So
Yeah,
the
I think
gradient is
Desire gets it correct. So the gradient is 3, and the trick here was convert that into a correct equation of the straight line, and that's how people lost it. I don't want to sample again the names of those who gave us wrong answers, but it is learning practice. Now get ready for the last question. I'm going to give you an equation. Please give me the gradient. I'm only interested in the gradient, not anything else. So please, the names that are in the chat and you gave us wrong answers, please get ready to correct this. Number 4. Question is there. 3x plus 2y is equals 10. I only need the gradient. So I'm going to open the chat when you're ready. Let me assume you're ready. Okay. What is the gradient? The chat is open. There are those who wait for people, then they copy. What is the gradient? 3 over 2. Rahim, please write it correctly if it is 3 over 2. The keyboard can allow you write 3 over 2. Melissa says 3. Desire says 3. Zawedi says 3. Heruth says 2 over 3. Yeah, negative 2 over 3. Now here, there are problems. There are problems. Some have negative, some have positive. Melissa, what is it?
So I would like to give how I got
Okay.
my answer.
Okay, let's see. Let's start with Melissa to give us what she believes is very correct. Melissa, you giving us something correct or you want to test?
I want to test.
Yeah. Okay. The equation is 3x plus 2y is equals 10.
We divide each of the numbers by the 2.
By 2. Yes. To give us
Then
3 over
3x
2.
plus y. Yes, 3 over 2 x plus y equals 5.
Correct. This is a correct step mathematically. This is correct.
That's where I stop.
Oh, this is where Melissa stops. Now, is this the equation of the straight line? Melissa, first tell me the equation of the straight line. Melissa. First repeat for me the equation of the straight line.
Y equals mx plus c.
Y equals mx plus c. What is supposed to be the first on your equation? Let's use the equation of the straight line. What is supposed to come first?
Y.
And then the next thing is what?
3 out of 2x.
From y, the next term is equals. Have you seen?
Yes.
In other words, nothing should come before equals. It should be only y. But for you, before equals, what do you have?
3x over 2 plus y.
So recollect that. Can we get someone else to complete this? She has given us, Melissa has given us a good start. Someone should now come and complete this. I saw many hands up. M Joy. M Joy, please take on.
We shall say 3x plus 2y 2y equals to 10.
Yes.
So this side we have only to remain with y. What we shall do, we shall get the 3x. We make it to cross the equal signs to go this
This
side.
one to close. Okay.
Then
So
we
how do
shall
you do?
remain with 2y equals to negative 3x minus 10
Is it minus?
plus 10.
Correct.
Then we shall divide 2 on both sides.
Good.
Here we shall remain with y equals to negative 2x, negative 3 out of 2x plus 5. Then our m is negative 3 out of 2.
Correct. M Joy, M stands for what? Which name is that?
Mukobejoy.
Mkovejo. This is good. And that is correct. Whoever has that, please clap for yourself. This is correct. And for those who were getting stuck here, please, Joy has told us clearly that don't allow anything to be on this side. So, so that's why we have that as that. I know there is no question. I want us to go to what we are supposed to study this afternoon. And I'm going to lower everyone's hand. Of course, if there is any hand, please put your hand up and ask the question. Or else I want us to go to the next thing. Any questions, please ask if there is any question. No question. I'm going to clean this. So in today's lesson, we are going to talk about parallel lines. When you're given parallel lines, what do you say about parallel lines when it comes to their gradient? And parallel lines are going to help us do so many things. And maybe someone should tell us what parallel lines are. Parallel lines in the first place, or what do you know about parallel lines? Is there anything you know about parallel lines? Let's start with Alisa. Alisa, please tell us something there.
What do I know about parallel lines? Parallel lines are lines that do not meet. Straight lines that do not meet. Yes.
Yeah, they do not. They do not meet. This is correct. This is correct. Aaron is telling us. Aaron, what do you know about parallel lines?
So parallel lines are lines which do not meet.
Yes, they do not meet. Aaron, that is correct. Rahima, Rahim. Yes, Rahim. Rahim can't open the microphone.
Parallel lines are two or more straight lines in the same plane that are always the same distance apart and will never intersect.
Okay, that is too detailed, Rahim. That is very correct. They're in the same plane, they are going in the same direction, and they will never meet. Pedro, you had something to say. You must say before I give the chance away.
They said it.
I want to know what they said. What was that?
They go in the
You
same
must.
direction and they do not meet.
Okay. Yes, that is correct. And everyone has told us they go in the same directions and they don't meet. I wanted to show you my polylines. Please go to your graph books and draw some one polyline at least. And I have a polyline here that I wanted us. We are going to use GeoGebra to demonstrate this. GeoGebra looks like that. So you can download it and maybe have it, but not for now. What is important for now is to have your graph paper, because me, I don't have a graph paper here. So I want to show you if they say a line is parallel, how does it look like? I'm going to sample a line here. I'm going to put, maybe I'll put it here. Then I'm going to put another line here for you. This one here. What is helping me know that these lines are parallel is that when you look at them, they are going in the same direction. I'm assuming if this is my direction. I'm assuming if this is my direction, maybe they are going downwards like this same direction. You can see that the distance between them is the same. When you have a pencil or if you have a ruler and measure, you can see that this distance is the same. And these lines, chances are so low, or actually there are no chances that these lines will ever meet. They continue going in the straight line. The best way to apply this for those who come from places where there are electric poles. Yeah, you find those two lines. If they are three, they'll put them in the parallel such that the live one and the earth thing, they cannot meet. And if you measure the distance between the two, it is always the same. And many other areas where they apply this. So these are called parallel lines, and I expect you to have some of these parallel lines in your books. So my parallel line that I have drawn is at point -4 and the 5. -4 and 5. And here is at 7, -3. For those who are able to read, I'm writing these points here. So the other one is this. It is at -2, 6. This is 6. Then this is at -2, I think 9, like that. That is an example of a parallel line, and I know you could have also seen parallel lines in your books. And there are many parallel lines, but that is just a sample. I can show you another example of a parallel line. It can move from here like this. And it reaches there. Then this one is starting from here up to here like that. Those are also parallel lines. The distance between them is the same always. And I'm going to show you a sample of parallel lines in mathematical sense, and you're going to plot it in your book, and later we are going to see how to work with them. Parallel lines, the example of a parallel line is this. Please plot that in your book. 1, please plot this in your book. It is A, 1, 2, then B is at 2, 5. Plot that. Plot for me A and plot for me B. I'm going to try it out here. My A is at 1 1 is here, 2 is here. Then my B is at 2, 5. 2 is here, and 5 is here. Yeah, that is the line segment I want you to plot. And please start by plotting this. I want you to plot that in your book. And please don't forget to put the coordinates. This is 1, 2, and this is 2, 5. Okay. The first question here is, give me the gradient of this line. What is the gradient of that line? I'm interested in the gradient of that line. Please plot it. Give me the gradient of that line. Plot that. Give me the gradient. I'm opening the chart such that you can post the gradient. The gradient is 3 according to Mixer. 3. Someone has said the gradient is 3. Yeah, almost everyone is saying the gradient is 3. Okay. The line that is parallel to AB is this. Please plot it also. The line is 3, 4, 2, and D, 5, 5. Now, why are you doing this activity? We want to discover another very important rule or a very important principle about parallel lines. Everyone was saying they don't meet, have the same distance. We want to discover another very, very key, and it's the most applicable principle about parallel lines. So we are going to plot. We are going to plot our line. We are going to plot our line segment is 4, 2. 4 is here. 2 is here. 4, 2 is our C. And the next one is 5, 5. This is 5. 5 is here. 5, 5 is here. 5, 5 is there. And please tell us those points. This is 5, 5. This is 4, 2. This is 5, 5. So this is the gradient of the first line, which everyone is telling me it is 3. Now give me the gradient of the second line. People are writing 3, or they are meaning the previous one. Use it. Please now, let me close the chat. Please write a complete answer and say M1, the first gradient, is equals 3. We had confirmed that. You put a comma and say M2, which is the second gradient, equals maybe 5. I'm just assuming, and put your name at the end like that. Then you send at once. M1 equals 3, M2 equals 5, and you put your name at the end such that we know that the first gradient you got it as 3. The second gradient you're getting it as 5. I've not tried out the second gradient, so I don't know whether that is correct. I shouldn't be the one failing. Please write. Don't forget to put your name. I want to read about 1 or 2 people. We go away from this part. Mukisa said the first gradient is 3, the second gradient is 3. Is this possible? Harry is confirming, Desire is telling us the same. Sabira is telling us the same. Jimmy is telling us the same. Marisa is telling us the same. Are people copying and pasting? Okay, let's close this. Let's try another one. I'm going to put a line segment here that is parallel. Let me put it here. I'm putting it in an open space. But people are very good at values that are positive. Let me use positive value. My A is here up to here. And then another parallel line to this is this. Let me put it here. Okay, let me put these two parallel lines. I want you to get for me the gradient for this, the gradient for that. Tell me the first gradient, the second gradient. Tell me the first gradient. Tell me the second gradient. These ones are also parallel. And we see if you did not cram or you know what you're doing. Of course, the value for A here is, you can read this, I know you can. This is 2, 5. Then this is 6, -2. Then this one, please try, as I try out as well. Okay, let's try the gradient for this. It has fractions. I've just tried it out here. So here is 5, 6. This is 9, -1. So like that. Of course, I've closed the chat deliberately. I've also closed the microphones. I want people to try out. So let me open the chat and I want to see the answer. Me, what I have got, let me just sample. M1 is equals, let me just write fractions, 1/3, comma, M2 is equals maybe 2/6. Then you put your name at the end. Like that. That is the answer I want to see. If it has fractions. If it doesn't have fractions, write normally. M1 is 7 out of -4. 7 out of -4. Mixer has told us that. Let me see. Yeah, M1 seems to be correct. I want to get M1 and M2. Please get for both. Venus is the same like Mixer. Isabella, your hand is up. Can I know why your hand is up? You're not giving me the answer. Okay, can I get the answers?
I wanted to give the answer, but I might write it in the chat.
Okay. Janet has, okay, M2, as if it is the same. Jimmy has that, Desire has that. Mkisa has now discovered that. M2 is almost, maybe there is. Okay, let's do the last one. Those who have not written, you're going to write, no problem. So let's do the last one. The last one is here for those who are using the graph papers. Pair 2. The first one is A01 and B is 2, 7. So I'm going to try that out here. A is 0, 1 here. Then B is 2, then 7. Okay, I don't have 7 here. Let's see. Okay. A is 1, 0. 1, 0, 1, which is here. Then the other one is 2, 2, 7. Around there. Give me this gradient. Give me that gradient, the other one. Then the other one is C is 3, 1. And D is 5, 7. Give me that gradient as well. I may not go back, but please get the gradient directed here and we get the answers. So we are considering this. Give me gradient 1. Give me gradient 2. Gradient is the slope, in other words. So for those who have tried out what is M1 and what is M2, then someone should compare using those answers that we've been getting to make one general rule. What is known about the gradient of two parallel lines? I'm opening the chart and we see what you have. Tell me the first gradient. Tell me the second gradient. Please put it in the chat. The first gradient, the second gradient. What is it? Joy says both of them are 3. Here, M1 is 3, M2 is 3. That is Mukisa. Jimmy tells us it is the same. Okay, someone should now put up the hand and tell us the correct principle. What is supposed to be known about the gradient of two parallel lines? You can even read about it, maybe online or anywhere, and make for us that general rule. I'll put up down your hands. Can you put your hand up if you've discovered what could be known about parallel lines? Yes, Ari?
Two parallel lines have the same gradient.
Yeah, the gradient is always the same. Okay, thank you, Ari. Then Mikisa? Mukisa, what have you discovered?
I even wanted to say they have the same gradients.
Have the same gradient? Okay,
Yeah.
Desire?
Two
Zero.
parallel lines that move in the same direction and have the equal length have the same gradient.
Okay, so in primary, there is a principle that they didn't give you, told you same direction, distance between them, and they don't meet. Now, all of you are confirming that there is a new principle that they have the same gradient, like Desire has told us, and many other people. So, we are going to base on that principle and conclude and say, please take a screenshot of the next pairs because we will not try them out, but the pairs are here, up to 4 of them. But the principle we are writing down in your book, please write and say, parallel lines have the same gradient. And please write and say, parallel lines have the same gradient. And maybe let me add this, have the same gradient. Let's add this and say M1 is always the same as M2. M1 is always the same as M2. This is a principle that you should take away as you're going back to your respective schools. It has the same gradient, and M1 is always the same as M2. Once the question says the gradient of these two lines, and then once they say these are parallel lines, just know the gradient of those lines are the same. So we are going to use that principle. Please take a screenshot, and we are going to use that principle to solve the next questions. And this is where our lesson is going to start from. For those that are joining in, we want to solve problems that involve parallel lines. So the first question is there. They are telling us, okay, maybe the first question is so simple. Let me ignore that. Let's use the second question. Find the equation of a line parallel to that passing through the point 1, 6. They are telling us you have been given a line y is equals 4x minus 2, and it is passing through that line. Okay, so they want us to find the equation of that line. In other words, this is what the question of the problem is saying. If this is the y and x-axis, there is a line which is called y is equals 4x minus 2. And it is parallel to a certain line that is passing slightly up here at so this line is passing at a point. I'm assuming this is 1, then this is 6. Maybe 6 is around here. So there is a line that is passing around here. That line is passing around the point 1, 6. So these are two lines. The first one, which is this line, and you know its gradient, which you know the answer, you know that gradient. This second one is here, which is having also a gradient that we know also because they are telling us they are parallel, and they want you to write that equation. Now, this is where mathematics of senior 3 starts from. They have given you the first equation. Oh, I wish I drew this in red. I'm going to retrace. I want to make this red. This line in red is the one they have given you. Now they are telling you there is a new line that is passing through 1 point. Remember, to get the equation of the line, you need 2 points. These people are giving you only 1. So, and they have told us that 1 point is at 1, 6. How do we get the gradient of this line? I'm going to try it out with you such that you do the next one. They are telling us that the equation that is parallel is 4x minus 2, like that. So that line is given, and they're telling us we need to find an imaginary line, but it is passing through point 1 and 6, like that. So we want to get the gradient of this line. It's what we want to look at. Please watch this carefully. This is an imaginary line, and it's the one they are asking us to look for. So I'm going to say our formula is y is equals mx plus c. And what is known is that we have the x, we have the y value. So we are going to substitute where there is y, I put 6 is equals m, and our x is 1, then plus what? C. We are looking for the value of the constant, remember. But now when we are looking for the value of the constant, this C is what we are looking for. But we can't find it. Why? Because we don't know the gradient. And this is where the concept of parallel lines comes in to help you, because it says, yes, you're looking for the constant C of this imaginary line that is passing through only one point, but you don't know the gradient. But they are telling you that this line that is imaginary is parallel to this. And remember, the gradient is always the same. So here we come and now boldly write and say, but since they are parallel, then M1 is equals M what? 2. So we will now say our imaginary line has the gradient of 4. So it is going to be this 4 multiplied by 1 plus a constant. So this becomes 6 is equals 4 plus a constant. C is now the same as 6 minus 4, give us the constant as 2. The constant of the imaginary line is 2. This is the line that we are looking for. We've got its constant as 2. So we can now come and proudly write and say, much as the line was imaginary, but its equation of the line is this. So we write and say y is equals, because it's imaginary, but it is parallel, its gradient is 4 plus 2, like that. And this is going to be the equation of the line that is imaginary. Remember, they have given you only one point, but you're able to find that gradient. So this is how we write the equation of the straight line if it is imaginary, but they have told us it is parallel to the other one. Now, please go through this very well. Ask your question, I answer it, I give you one example you look at, and we leave the meeting. Please put your hand up. It will be very bad if you don't ask any question here. I know this knowledge could be much. But if you've understood, well and good, you're going to try in the next one. If you've not understood, please put your hand up. Ask at which point you didn't get it. I say something about it. Then we try out example number 2. Any hand? Yes, Mkisa?
Teacher, I did not understand even single step.
Okay, now that one is very unfortunate for you. You will have to wait. But if you understood at least somewhere and you are getting lost from somewhere, those are the people I'm looking at. For those who did not get anything, I'm going to repeat probably in the next exam. Any hand? Okay, can I see those who have understood how to get that equation of the straight line that is imaginary? Isabella, 2 people, 3 people, 3 people, 3 people. Let me hear from Venus. I've not heard from Venus since. Venus, did you understand that? Venus, can I hear from you, please?
Yes, teacher, I understood.
And do you see the importance of the principle that we discovered that M1 is equals M2?
Yes.
Why is it important?
It helps us to know the gradient of a fellow parallel line.
If it is not given.
Yes.
Okay, I think that is correct, Venus. Anyone, of course, I'm going to sample any hand that is up at random to tell us the importance of M1 is equals M2. Is this principle important? Please don't leave your hand up if you don't know that. Because I'm going to sample at random. M1 is equals M2 is what we have discovered important. Galaxy A02, tell us your name. Galaxy A02. Galaxy A02. Your name is what?
My name is Mungutia Jolie.
Joel?
Jolie.
Jolie.
Yeah.
Okay. Is M1 equals M2 what we discovered important? Do you see how we used it?
Yes.
Okay. Why do you think it's important?
It will help us to get the gradient if it is not given.
Yeah, if it's not given. Yes, Jimmy, do you want to add something? Jimmy, your hand is up. Jimmy, or someone
Not
using
really,
technology.
because you basically said the same thing that I was going to say.
What
In
were
the
you going to
event
say,
when you're not,
Jimmy?
what I meant to say was, in the event when you're not given the gradient, and then you've been given an equation, but it has the gradient, you can use it to find the equation of a straight line. Like when you've been
Okay. Okay, that is correct, Jimmy. And can we use that knowledge to try out this second question? Please let's do it fast because of time. Write the equation of a line parallel to this, passing through the point that. Now I want to see mathematicians. Yeah, as mathematicians are trying out that, of course, I know some people have not understood. I'm going to repeat using example number 2, but maybe before that, let me hear from, I saw this hand for Mokisa. Mokisa, please bring back your question if it's there. Mokisa?
So now I've understood why M1 is equal to M2 is important.
Okay, what have you understood?
Understood that you substitute the value. Now you know that if M1 is, for example, 3, now you will know that the value of M2 is also 3. Then there you substitute in the equation there.
Okay. Can you use that knowledge to do number 2, Mixer?
Okay.
We're going to use the timer. I want us to use only 1 minute. on this 1 minute, exactly 1. So this is senior theory. If 1 minute is over, please you share your answers. Let me put the timer here. For those who are joining in, please, we are doing number 2. Number 2, it's a parallel line, and they are telling us it is passing through a point that. So in other words, it is an imaginary line, but they've told you it is parallel, so you can get for us that equation much as it is parallel, and it is imaginary, and they've not given it to you. You don't know its gradient, you don't know any other point. Get for us that gradient and use it to get the equation of the straight line. In 1 minute, we have now seconds, but let me restart this. I've added you 1 minute. 1 minute now. Immediately the 1 minute is now over, but I see Arafat's hand is already up. Arafat?
Number 1, find the equation of the line. You identify the slope of the parallel line. A parallel line to y is equal to 4x minus 2 has the same slope where the gradient is 4. So the second step, use the point slope form to find the equation. X power, using the point x power 1, comma, y power 1 is equal to, open brackets, 1, comma, 6, and slope m is equal to 4 in the point slope formula. Y minus y power 1 is equal to m x minus
Which
x
which
power
question
1.
is that? Or question 1 or question 2?
Question 1.
Question 1. Huh? Now we are on question 2. Question 2.
Yeah, okay,
Arafat,
question.
but before you give this to us, write that equation in the chat. Let me open the chat for everyone. First, put your equation in the chat before I give you a chance to try out, because we don't have time. I want to pick a person who has got an equation that maybe is correct. Okay, let's write. Janet has told us the equation is y is equals -2 x plus 5. Janet has told us, Janet, let me help you rewrite this. Well, Janet, you'll rewrite as probably plus 5. This is Janet. Okay. Most people have this. Most people have that. Janet was the first to give us. So I want to find out if Janet can give us the correct answer for this. Janet, are you ready to talk to us? And many others, of course, Venus, Akosa, Isaac, Hatima, all these ones are giving us. Joel is also giving us. Joy is giving us. Nancy, and so on. Janet, are you ready to take us through?
Yes.
Okay, please go ahead.
Okay, so they gave us the x and y as 3 and -1.
Yes.
So I substituted and I said -1 equals m into 3 plus c.
Yes, then you substituted.
-1 equals m into 3 plus c. And since they are parallel lines, the gradient is -2. So -1
Yeah, so this is gradient is also going to be negative 2, correct?
Mm.
Mhm.
So it will be negative 1 equals negative 2 times 3 in brackets plus C.
Yes.
So I got negative 1 equals negative 6 plus C.
Hello? You call something like that. Okay, I beg your pardon, Janet. This is C.
Negative 1.
C is now going to be, okay, sorry, I think I missed the step. This is C. Negative 1 will be equal to?
Equals negative 6 plus C.
Yes.
Then I got C as 5.
So our C becomes 5. I think those with 5, as you see, put your hands up and we count. Anyone who has got the constant as 5? 3 people, Arafat, Kevin, Venus, Isabella, Kakoza, Darren. I think only those ones. Who else? Rahim, Stanley, Joy, Priscilla. Okay, 11 people. Good. It makes what this graph is telling us correct. Proceed. Write for us the equation.
Y equals negative 2x plus 5.
Negative 4x plus 5. And this is correct. I saw everyone with this answer.
No,
So
negative
this is
2x.
negative 2x. Yes, correct. Negative 2. X, which is the gradient, plus 5. So this becomes our correct equation of the line that is imaginary, and it is parallel to this line that they gave us. And how do you know that it is the same? It is parallel because the gradient is the same as negative 2. Yes, so I want to leave it at that for these parallel lines. For those who have not written it down, please take a screenshot. We finalize by talking about the particular lines quickly here. So, yeah, as you go back to your schools, this is a principle you need so much about parallel lines. But we have parallel lines, we have perpendicular. There is this question also for those who did it first. There are 4 of them. Please take a screenshot and try it out. The gradient there is a half. The next one, the gradient is not known. How do we go about this? How do we go about that? So you will try that in your free time. Take a screenshot. And I want to give you with the last principle about perpendicular lines. Perpendicular lines look like that. So I'm going to try out this. Please try out the perpendicular line in your book. A perpendicular line, they meet at 90 degrees. So this is my B, and this is my C, 2, 5. Please write those coordinates down, and we plot them in our graph for you to see how perpendicular lines look like. This is perpendicular lines, and of course perpendicular lines meet at 90 degrees. And I want to try my GeoGebra and see how the perpendicular lines look like. The first one they're telling us it is at 1, 2. This is 1, 2 is here. Then B is at 2, 5. 2 is here, 5 is here. Okay. Then they're telling us C is at 2, 5. C is at 2, 5 here. Then D is at 5, 4. 5, 4. 5, 4. Here like this. I just want to produce this to be a straight line. I'm just producing it like that. I'm just making it longer. Then I'm also making this longer. So let me just leave it at that. Perpendicular lines are lines that meet at 90 degrees. So we can say that this line is perpendicular to this one. So I wanted you to discover the gradient, but we may not have enough time to discover because time has gone. But these are perpendicular lines. If the line is moving like this, one that cuts it at the exact 90 degrees. Take note, if the line is like this and you pass like this is not a perpendicular line. Why? Because this angle is not 90 degrees. A perpendicular line, if it's like this line must make 90 degrees angle. Then we say that is perpendicular. Or if it is flat, the better. You can even see it well like this. So perpendicular lines look like that. I know you know them. But what is important here is to discover what is known about their gradient. So someone should tell us the gradient for line 1, the gradient for line 2. Please try it in the book and write it in the chat. The gradient for line 1 and the gradient for line 2. I've left the chat open as I also try out the gradient for line 1 is 5, 4 minus 5. Please give me the gradient of M. Oh, don't fear to write. I know the answer looks different, but write. My first gradient is 3, and I'm going to write randomly the gradient of 2. And line 2, I'm going to write it randomly as negative 4 out of 7. Then I put my name, Maslaba, at the end like that. That is what I expect from some of you. The first gradient is correct. The other one I'm deceived. You can discover the gradient of the second line. Arafat and others who are putting up the hand, please write in the chat. We want to see the answers. Oh, I closed the chat, sorry. So, can we write the answers? Give me the gradient of the first line, gradient of the second line. Gradient of the first line. Mukisa tells us first gradient 3, second gradient negative 3. Okay, Mukisa has told us that. Jenny tells us first gradient 3, second gradient is 1 over 3 negative. Okay, Isabella has negative 1 over 3 for the second gradient. Isabella, I'm waiting for your first gradient. Jimmy tells us, Jimmy, I think your answer is correct, but you're missing out something. Jimmy, write your answer, especially for the second gradient. Joy has the gradient as 3, and the other one 1 over 3 negative. And everyone seems Matthew has this, Isabella has that, Stanley has that. Yes. Okay. I think that is correct. I'm going to write it here. The correct answer is M1. The gradient is 3. Then M2, the gradient is negative 1 out of 3. That is correct, even the answer that I have here. Also, this is for question 1. Okay. Now, whoever has not got, yes, Joy has now confirmed. Jolly has also confirmed that. Mukisa has confirmed that, and everyone. Okay, let me close the chat. Now, I want to confirm if someone is not guessing and you're getting this right. Can I see the second one line? The second pair is 0127. 27 D is 85. Please give me the first gradient. Give me the second gradient. I'm waiting to write it here. I'm going to try out and get the first gradient, which is A, B. This will be 7. Okay, my answer is, I'm giving you the correct gradient, which is easy. The first one is 6. Whoever has 6, good. Then the other one, I'm going to deceive. The other one, let me say, is 7 out of negative 7 out of 9. So the second gradient is wrong. The first gradient is correct. Please confirm your answers. Give me the first gradient. Give me the second gradient of question 2. The first gradient is 6, and the other gradient. For those who are joining in, reminder, we are getting the gradient of lines that are perpendicular. Lines that are perpendicular meet at 90 degrees. What is known about their gradient? I'm waiting to see the answer. Yeah. Isabella says the first one is negative 1 out of 2. Then the second one is 6. Isabella, please check your second gradient. Did I write it wrongly? I think I've written this wrongly. Written this wrongly. It's supposed to be 6. This is 6. So, please let me close the chat. You seem to have the correct idea, but I have written my wrongly. This is not 5. It is it is 6. This is 6. Please repeat this. Not available. That is 6. Okay, I will of course start by pasting mine. That is already here. And wait to see what people can get this side. Okay, the chat is open. The chat is open. I want to see. Yes, Muksa is confirming. M2 is negative 1 out of 6, correct? M2 Isabella confirms, correct. It means it's my coordinate that had the issue. But yes, Janet has confirmed. Venus has confirmed. Venus, it is M2, not M3. Stem has confirmed. Okay. And this what is important here is that question 2, M1 is equals 6. M2 is equals -1 out of 6. It's something like that. Now, I don't know if anyone has generalized. I don't know if anyone has seen this, but it is like this. If my M1, look at that. If my M1 is equals 5, what is going to be my M2? I want to see if someone has discovered the trick here. My M1 is 5. What is going to be my M2? It has to be negative, first of all. But what is going to be my M2? Let me see. Mukisa, if my M1 is 5, what is going to be my M2?
M2, the M2 will be -1 out of M1.
-1 out of M1, which is what?
Which is 5. Which is 2.
Which is 2 again, it is 5. Okay.
Which is 5.
If I have my M1, thank you, Mikisa. Let me try again. Please look at that rule. We want to write a rule here before we go, because this is our last lesson. If my M1 is 8, what is going to be my M2? Someone should discover that M2. Starts with negative. Joy, you've been good. I assume you see that. What is going to be your M2?
-1 out of 8.
Correct. -1 out of 8. Okay, let me stamp again. If my M1 is, let me see, 13. My M1 is 13. What will be my M2? Let me see, Isabella.
Teacher, your M2 will be -1 out of 13.
-1 out of 13. Okay, the last one. If M2 is -4, people understood the trick here. What will be my M2? If this time round, M1 is negative. Arafat? Arafat has forgotten the hand up. Venus?
1 out of 4.
1 out of, how did you get 1 out of?
When I say -1 out of -4, the negatives cross out and then it becomes 1 out of 4.
Okay, so you say the answer is put the negative, then get the reverse of that, which is -1 out of 4. Like that. Then the negatives cancel out, giving us the answer was M2 is 1 out of 4, like that. So Venus has confirmed this. Now, who can generate for us the relationship between M1 and M2? What is the general relationship? Such that we say whenever lines are parallel, this is what is known. Who has seen that? For you to discover this, let's come back here. Please multiply for me M1 times M2. Please, for item 1, get M1 and multiply it with M2. Give me the answer. Multiply for any line. That is how you're discovering the trick. Any line, even here, you can multiply M1 and multiply it with M2. Which answer do you get? Even here, try to multiply. If M1 is 5, M2 is -1 out of 5. Get M1 and multiply it with M2. What answer do you get? Can I see this in the chat? When you multiply -1, Janet has got -1. The product of the perpendicular line is -1. Good. Multiply, multiply, multiply. Hatim has got -1. Stanley Jolly confirms it's -1 for all. You realize that the answer is -1 for all of them. I'm waiting for some other people to confirm. Please pick anyone, any number. Get M1, multiply it with M2, and we see what your answer is going to be. Kakoza has confirmed it's -1. Perus is -1. Jolly, Stanley, Hatim. M2 is the negative reciprocal of the original gradient. Janet now has put in a lot of English, which is correct English. And we want to generalize and see. M1 times M2 is equals -1. Now, this is what that is meaning. Let me sample for you here. The rule says if your gradient 1 is 5, the rule says if they are perpendicular M1 times M2, the answer is always -1. So the rule says if you've been given M1 but you don't know M2, you come and substitute where there is 5. So this will be 5 times M2 that we are looking for is equals -1. So when you divide through by 5, because we are looking for M, divide through by 5, divide through by 5, our M becomes, our M2 becomes -1 out of 5, like that. So in other words, the gradient, if they say they are perpendicular, just say M1 times M2 is equals -1. And once you discover that, no perpendicular line will refuse, no parallel lines will refuse as well. So I want to leave this principle here, then we go. The principle, of course, there are so many lines. If you have time, you can confirm all of them. But the principle says perpendicular lines, the rule is for perpendicular lines, M1 multiplied by M2, the answer is always -1. So if you're given M1, you don't know M2, put and it will be the reciprocal, like that girl had said. So this knowledge is going to help you solve so many problems as we go. I'm going to leave an exercise on your screen. Try it out and please post the answers in the chat. I mean on WhatsApp. I'll find time and go through. Stanley, do you have a burning question?
Yes, sir. Like,
Mm.
we can't put that negative down.
We can't, yes, the negative can be down. Of course, if the negative is down, the whole fraction is negative.
Okay.
Hey,
Thank
you
you,
get
sir.
that? Yes.
Yes, sir.
Okay. So, other than that, that is what I wanted to show you for perpendicular lines and for parallel lines. Let's leave it here for now. Please find time and try out this exercise. It has both perpendicular, it has both parallel. For perpendicular, try to go more about the examples. But you have the principle, but for parallel, I know you know what to do. Let's try that out. I want to end the lesson here. We've entered in about 18 minutes, but because we are winding this up, I didn't want to leave anything behind. Let's leave it here for now. If there is any question, ask. If there is no question, please, we get a volunteer to give us a closing prayer. Dan, Daddy, is
Yes,
it a
please,
question?
sir.
What is it, Daddy?
Pardon?
What is it? Is it a question or a closing prayer?
A closing prayer.
A closing prayer. Okay, Darlene is going to give us a closing prayer, but I want to give chance to anyone if they have a question before Darlene gives us a closing prayer. I'm putting your hands down all, and if no hand goes up, then we'll take on from there to give a closing prayer. Let's ask something, if there is anything you must ask. Okay, no question. Darling, you can give us the closing prayer. Darling, you're breaking. We can't hear you. Okay, Darling is breaking. Let's get Isabella to give us the closing prayer.
Let's humble ourselves for a prayer. Father, Lord, we thank you for this day. We thank you for the lesson that you've given us. May you please guide our teacher and may you enable the knowledge that we have attained from this lesson to stick with us, that we may remember it. And may you keep us safe as we go to school. In this reason, we are afraid and believe. Amen.
Amen. Thank you very much, Isabella. Let's leave it at that. I will leave now the microphones open for at least anyone to test, and probably the lesson can end.
Thank you, teacher.